Okay. Oh, yeah, look at the daughters. Nobody cares. Okay, but anyway. All right, look up here. Shh. Silence of the Lambs. All right. Does anyone know that movie? No. Okay, now. All right, so did you get that chart right there? Drew, are you just saying that or did you? Okay. All right, and then this chart, you get this one. Okay, put above each one. The first one actually represents an arithmetic scenario, because it goes up by 5 each time. So you start the first day running 15 minutes, then you want to challenge yourself and add 5 minutes each day after that. So that's a +5 difference each term from one to the next. The next one, I believe, was breadcrumbs, and it looks like we're multiplying by 3, right? So after 18, it's 54, then 162, then 486. Did you get those? Get a little buzzy in my ear. It's weird. Maybe my ShamWow here headphones are a little bit broken. Did you get 60? I heard a lot of people say 60 on that, right? Right. And then the other one's for 90 minutes on July 16th. How many minutes will she run on the 18th? That's just 5 and 5. So 100 is hopefully what she should have got there. Right. And then big numbers on this last one. Okay, still a multiplier by 3. So you have to multiply by 3 twice in order to get that last one, 9 million something. Okay, so obviously the one on the right increases much quicker, like it starts ratcheting up. That's because the word for the day would be exponential. Can everyone say exponential? Good. All right, and then I don't care about this writing. I want to move on. So it's just the point of actually filling that out, and then we're actually going to go into the notes now. Like I said to you guys before the video, notes are going to be longer because of setup than your actual homework you're going to have to do. It's really just 2 things to memorize. Well, the first scenario, when we added 5, that's actually arithmetic, right? And I think I may have already said that. The second scenario is geometric. The 2 things you have to memorize are the 2 formulas, arithmetic and geometric. And that's what I'm going to build up here for you. But these are called sequences. Oh, okay, the timer just went off. You scared a student, sorry. All right, and a sequence is this. How did these work up above there? What were the inputs? By the way, say it, input what? Okay, what were the inputs though? The inputs were days. Day 1, day 2, day 3. I think both of them were days, I believe, but at least the running was. So you have to understand that's a discrete scenario. Don't get scared of that word. What it means is our inputs are only integers. Day 1, day 2, day 3. They're not decimals. And that's what a sequence is. You have a first term, a second term, a third term, and you actually have to plug in 3 into some formula to get the third term. That's how it works. Okay, so that's what we're going to be working on today. What kind of formula, what do these formulas look like? If you could just think about that, this should be a pretty easy day. But then I always get worried about what happens after the fact. All right, so let's hopefully focus and make this easy. First thing is this: we will not have function notation anymore in this section, this particular scenario. We'll have what's called sequence notation, which is just this. This really says the same thing as f of n, but a sub n, if I have f of 1, it would just be a of 1, and therefore you plug in 1 into some formula to get a sub 1. So it works the same way, it just looks different. And then we'll just get to it. What is an arithmetic sequence? An arithmetic sequence is literally linear. The common difference is actually going to be our slope value. Now, this definition isn't the greatest. This is called a recursive definition. This is not a good formula definition. Don't worry about the word recursive. We used to get into that all the way. Recursive means, how do I get from one term to the next? Well, I just keep adding a common difference to get to the next term. I just keep adding it and adding it and adding it, and then I get more and more terms. That formula is not as useful as one I'll show you here shortly. But here's some other stuff. This is a rule. When you're given a list, that list is now a sequence. that sequence, that term that you see first, that has to be considered a sub 1. So put this above. So I'm given a list, 2, 5, 8, 11. Well, I'm given 4 numbers. The first number shall be called a sub 1. Therefore, the second number is called a sub 2, meaning the second term, third term, and fourth term. Got it? Now, well, first of all, what's the pattern? What's happening with these numbers? They're all going what? Up by what? 3. 3 is a slope value then. You're going to find out that this is actually a linear scenario then. And we're going to write an equation for it. But really what I want to do though is go backwards. I do want to know what a sub 0 would be then. And all you got to do is, instead of adding 2, do what? Subtract, or not 2, sorry, 3, right? I caught my mistake. So if I subtract 3, what would a sub 0 be? -1. It ain't no rocket science. Okay, so rule number 1. When you're given a list of numbers, the first number is a sub 1. It's got to be. A lot of times you do have to find a sub 0, but I'll show you some alternative forms that we could deal with here. So how could I find the equation for this scenario? What's happening here? Well, we could equate it to this and understand that that is the a sub 0 term. So this would be -1 here. I'm going to prove it by input, say it, output, but I'm going to write it in sequence notation, not f of x notation. And then what's the slope? The common difference, my silly little friends, times some n value. All right? Well, wait, what am I doing? I'm writing the equation of this actual scenario, so my fault. What is that common difference? 3. And now what should be able to happen is if I plug in 4, I should get what a sub 4 is, which is 11. So what's a sub 4? That's 3 times 4. What's 3 times 4? -1. What's 3 foot? What does that become? 11, which is the a sub 4th term. I usually like to check the last one to make sure it creates the term itself to check if my equation is valid or not. But I have a whole bunch of other things I want you to write, and this is the only way I could really think about approaching this so that you firmly and truly understand the scenario. Oh, let's go ahead and graph 2 first. Let's go ahead and do that. So 1, 2 are originals. Go ahead and graph these. You could do it. 2, 5. I'll just do it real fast, and you keep up, I guess. 3, 8. It is kind of hard with the small graph. And then 4, 11. Well, that's why I know it's linear. Look at that. Those connect and make a line. But you're not supposed to, because a sub 1.5 doesn't exist. It's just a sub 1, a sub 2, a sub 3. That's what we mean when this is called a discrete graph. You're not allowed to connect the dots. They're like separated. Okay, so no connection with those. Oh, and then didn't we find a sub 0? And a sub 0 was -1, proving the point that a sub 0 is the y-intercept. Right, so I did go backwards and graph a sub 0 now. Okay, but then I want you to write this down. I really, really do, because I really want you to understand that you have a whole bunch of options. Write that first formula again. Wasn't that the first one that we wrote? And put them next to this, or like somewhere around here on the right or above or whatever. So that formula works. It's good. But what if I wanted to put this in terms of the first term, which is the one that was listed? I didn't even have the 0th term. I had to find it. Well, then this formula is valid, and I want you to understand that it is valid, and it does create the same scenario. I'm allowed to plug in numbers for n and get the terms that I'm looking for. But I could start with the first term, but you're one away as far as how many differences that you need for this to get to the nth term. So therefore, that must turn into n-1. Now again, this is not a big deal. What happens when I plug in 1? What's 1 minus 1? 0. What's 0 times 3? What's 0 plus 2? 2. So I plugged in 1, I got 2. That's what's supposed to happen. Just like I plug in 1 up here and I get 2 in the top equation. So both of these equations are valid. Let's plug in 4 real quick. What's 4 minus 1? That means there's 3 common differences from a sub 1 to a sub 4. And that's why this should make sense. Well, let's just go back and be robots and plug in. 4 minus 1, 3. 3 times 3 is 9. 9 plus 2 is 11. A sub 4 is 11. This works. Or you could go to the second term and use that for your formula. But then you're n minus 2 away. So therefore, that must turn into n minus 2 in that situation. Again, when I plug in 4, what's 4 minus 2? I got it, it's 2. What's 2 times 3? I got it, it's 6. What's 6 plus 5, everyone? 11. So still, when I plugged in 4 into the third equation, I got 11. That means that formula is still valid. But wait, there's more. I could start with the third term, but then n minus 3 away. Or I could start with the fourth term, and then I went ahead and solved this one. So the fourth term was 11. And then notice when I distribute and add, yeah, that fourth formula turns into the first formula by simplification. So it's proof that all of these formulas say the exact same thing. They're able to generate my terms. But it gives us options depending on what terms are given, as long as you understand this. Okay, so again, this is the common difference right there. This is the term you're dealing with. That number is the term that was plugged into the formula. All right, and then that's how it goes. Okay, this is on the next page as well. And then I can go ahead and find a sub 100. I could have done that right away by understanding that formula there, but I did want to go off to the right and show you that you had actually 5 different formulas you could write since we found the 0th term. That's why I'm taping this. 2 years ago, we had a little different approach here. I actually made a mistake 2 years ago. This whole idea of the 0th in the first term was a bit confusing. I'm free to admit it. I don't care. It's fine. All right. So here's what you got to do first. You got to read. Okay. First of all, it says it's arithmetic. So it follows arithmetic scenarios. It follows this scenario, that I had up there. It depends what term you're given, though. So they give us the third term. All right. So knowing this is arithmetic, I know the format then. If I'm going to put the third term in here, then the multiplier on the common difference is n minus 3. Okay, so third, n minus 3 goes in there. So yes, this is a slope formula, kind of, but you're 3 off when you're starting with the third term. That must be an n minus 3 in that position. Oh, and I'm given a sub 3. So I can replace a sub 3 with that number 8. Oh, and I'm given the common difference. Therefore, I can go ahead and find my formula in simplified format. It's what I did on that last one. I didn't feel like doing it with all of them. When I plugged in a sub 4 up in that upper right corner there, then distributed and added, and it ended up being my a sub 0 formula, which is fine. All right, it's the same. If I would have done that to all of these would turn into this. All of these would turn into this by simplification. They all would. That's why they're all options for you. So I went with that option. So we really got to hammer this down. That formula A part of this, those match if you want to be a robot and stick the numbers in right. Really what I want you to do is understand the why. And then I'm going to go ahead and clean this up just because. And then just so you know what's happening here, 17 is the 0th term. And I can prove that. If I had a common difference of 3 negative, then to go backwards, I'd have to add 3, add 3, add 3. Here's a sub 0, here's a sub 1, here's a sub 2, here's a sub 3. And it works. So that's why 17 is the 0th term when you simplify this scenario. Whatever. I'm just trying to climb into your head so that you understand. How do I find the 12th term? You just simply plug in 12. This is a direct, what's called an explicit. I think I had the word explicit up there, but I think it might be in my next page. An explicit formula, a formula that allows me to find the exact number of that term just by plugging in. It's a great formula. I'm stalling because I don't know this answer. Is it negative 29? Does that sound right? Huh? 36, 26, 19. I was never good at math. It was my worst subject. All right. What? Is everyone okay? Ain't no thing. Math is what now? What? Okay. All right. So here we go. Let's write this on the next page. Because we do have options, and I do want you to understand that we could do something different here, and I want you to understand. There's better to understand where the formula comes from than try to memorize it. So try to listen. Because I do have to add this though, where k is the k term and n is the nth term. I want to add this. This is part of why I'm making this movie, because we should make sense out of this then. So how do I get from the k term to the nth term? I apply a certain amount of common differences, right? How many common differences? The difference between how far those terms are away from each other, because that's how far they are away on the list. So therefore, that's how many common differences I have to apply. So this formula right here, how far is it from the second term to the sixth term? How many terms is that, everybody? 4. That's why here will be 6 minus 2, which equals what, everyone? 4. Understanding is better. All right, I pause for dramatic effect. Now I'm going to put a 7 in for a sub 2, a 9 in for a sub 6, and then I'm going to do 6 minus 2 is 4, and then continue to solve this. And I'm going to throw this over here. Subtract 7. I'm not doing your grade school solving. Subtract 7 and then divide by 4. I guess I am doing your grade school solving. So that means the common difference is you're just adding a half. Okay, that makes sense. To get from a sub 2 to a sub 6, I'd have to add a half. A sub 3 would be 7.5. A sub 4 would be 8. A sub 5 would be 8.5. A sub 6 would be 9. I just added a half 4 times, and it made sense. Okay, so how do I deal with this next? Find the equation for a sub 24. You know what? You could stick with this formula here. I did something different with the other class, but I'm going to plug this into this formula. Plus d, which is a half. Oh, and then it's 24 minus 2. Because from a sub 2 to a sub 24 is 22 terms. Therefore, 22 common differences applied to get from that term to the other term. So that should make sense. And now I'm going to go ahead and plug in a sub 2, which is 7. You could have plugged in a sub 6 here, but then this would be 24 minus 6, 18 common differences from a sub 6 to a sub 24. See, really, that's what we're trying to do here. We being me and my many personalities. But when I have a few, it really depends upon third hour and what they do to me. Anyway, oh, are you okay or no? All right. But anyway, yeah, we'll leave that alone. What's half of 22, everyone? 11. What's 11 plus 7, everyone? 18. So the 24th term would be 18. If you added a half to a sub 6, let's say, 18 times, you get 18. It would happen. All right? It would work. Okay, now it's time for geometric. I hope I said this. Every time you see a list, what is 3? What number is that in the list? It's the first. I don't know if I did say that. I felt like I maybe didn't. Is this 5th hour? No, it's 4th hour. I took a whole other hour for my sandwich. All right, anyway. I know, thank you. So this is a G. Now, why are we using G? Because this is going to be geometric. Why is this geometric? What's the pattern here? How do we get from 3 to 6, 6 to 12, 12 to 24? What are we doing? Multiplying by 2. So now we're geometric. So what would G sub 0 be? How would I go backwards? divide by 2. So this would be 3/2. So, okay, and then let's go ahead and graph these real quick. That's why we got this really dramatic, big scale here. I did the counting for you. What was 4 comma 24? There actually literally are. The teacher that made this notes got you 24 boxes. So it is 24 all the way up at the top. And just for spreading this out to get better space, I just went by 3s just to spread out the 1, 2, 3, 4. But 4 comma 24, imagine that being the top. So 3 comma 12 is halfway, and then you can count 2 and 1. 2 comma 6, 1 comma 3. And I did put the 0th term there. Now you don't know this, but this actually is not linear. This is actually an exponential graph, which is what our whole subject's going to be about in this chapter. Well, it's going to be exponentials and then logarithms. For you math 3 people, you did logarithms. Okay, and then notice what I did here. Here is one formula. But what did I put it in terms of? A sub 0 times some r raised to the nth power, right? And that's what this formula represents. It does match this. You have to know a couple things, though. This could be problematic later. First of all, what's anything to the 0 power? What's anything to the 0 power? 3, 2, 1, go. It's not 0. It's 1. There's a reason for it. I don't feel like covering it right now. Nor would you need to see it right now. We'll cover that later. And then what's anything to a negative power? Flip. So some things that we have to know, like, I don't know, just pick a number. 1/2 to the 0 power equals 1. You know what 1/2 to the negative first power equals? 2. It's a flip. Okay, you got to remember negative exponents means flip and then raised to a power. So what's 1/2 to the negative second? It's actually 2 to the second, which is 4. All right, and those are things that we're going to have to know in the future. I think I just said I wasn't going to cover that, but I just kind of wanted to. And then do this again, right? 5 different formulas for this connection here, this thing. The first one is going to be the one that we wrote. And that is, if I'm dealing with the 0th term, then that's times that r value raised to the nth power. You writing this down, Drew? Net, I know. That's why I called you out. That's what I do, and that's why people hate me. That's fine, though. I don't care. Couldn't care less. Okay, some people do, believe me. But then look at what I did. I started with the first term. Well, then your power has to be n minus 1 then. So same r value, but I started with a sub 1 instead of a sub 0. That means the power must be n minus 1. Why? Input, say it. Someone said an output. When I plug in 1, this is why I just went over this. What's 1 minus 1? What's 1 minus 1? What's 2 to the 0 power? 1. What's 1 times 3? 3. So guess what? I plugged in 1 into the second formula. I still got 3. And that's what should happen. That's why this formula still works. Or I could go to the second term. Gosh, dog it. Okay, lost that. And then we got to put, what's the second term? 6. But then it's times 2 raised to the n minus 2. Why? When I plug in 2, let's do it again. It was fun. What's 2 minus 2? 0. What's 2 to the 0? 1. What's 1 times 6? I still plugged in 2 and I got 6. That formula still works. If I plug in 4, 4 minus 2 is 2. 2 squared is 4. 4 times 6 is 24. I do get g sub 4. It works. I'm giving you options. Or we can plug in the third term, but then it'd be n minus what, everyone? 3. Or I could do the fourth term and it'd be n minus 4. All of these formulas create that list over there. Now, I did talk about negative exponents. This is unfortunate. Say I plugged in 1 here, and I'm plugging in 1 into this one. It actually could be any of them. When I plug in 1 into this one, this becomes 12 times 2 raised to the negative second. What is that? That's 1 over 2 to the positive second, which is 1/4. This is where we're going to have problems if we don't know our old skills. I think everyone in this room should have been taught a negative exponent at some point. But anyway, what's 1/4 of 12? Say that number right there. 3. And that's what I plugged in. I plugged in 1. I plugged in 1 for n to get that -2 exponent. 1 minus 3. So I still got 3 when I plugged in n equals 1 into this formula. That means it still works. And it still creates the terms that I want. All right, so do remember that. There's the exponential. Because I'm going to use this for this one. So what am I going to use for this? I'm given g sub 2. Well, if it's g sub 2, then it's r raised to the n minus 2. That's what I just went through with you. If you're asking me why is it n minus 2, you listen to nothing I just said on the previous stuff, and that's why we fall behind. It really is true. All right. Oh, and by the way, the r value is 1/2, so why didn't I just write that? 64 times 1, because it's listed. It says it's geometric. As soon as it says it's geometric, it must follow this format. And then the format, I have to start with g sub 2 because that's what I'm given. So I'm stuck with this. All right. And then what I could do is find g sub 5. How do I find g sub 5? You just use the formula. 64, 1/2, 5 minus. Now, and then understand this too. How many common ratios do I have to hit g sub 2 by to get to g sub 5? The answer is 3. To get from g sub 2 to g sub 3, I have to multiply by something. I have to multiply again to get to g sub 4, and I have to multiply again to get to g sub 5. That's 3 multiplications. That's why this is 1/2 raised to the 3rd, which would be 1/2 times 1/2 times 1/2, which is 1/8. Not 1/6, that's adding. Hurrah! And that's what g sub 5 would be 8. If you had time, you could just multiply by 1/2 3 times as well, and that would be perfectly fine. A lot of times, though, we ask you to find g sub 32, and you don't want to do that. That's too many times doing that iteration, I like to say. Okay, so here's our general format for this. It really has to deal with how far away these two terms are. So I'm going to employ this rule on this next number 6. I wish something didn't happen with number 6. It's probably a little bit too complicated for you to start off, but I'm still going to go through it and hopefully you can handle it. But do understand g sub k to g sub n, how far are they away from each other in the list? N minus k, that's how far they are. That tells me how many r's I should multiply by to get from g sub k to g sub n. And hopefully you can understand that. So for instance, from g1 to g5, how many things should I multiply by to get to g sub 5? Well, 1, 2, 3, 4. There should be 4 times that I multiply g sub 1 by something to get to g sub 5 because it's geometric. That's why we're going to go right to this formula and understand it. To go from g sub 5, to go from g sub 1 to g sub 5, I have to multiply by some r value 4 times. That's what the 5 minus 1 means right there. This is not formula memorization. This is formula understanding. All right, and then I'm actually going to plug in those numbers and solve for this. This is where this gets a little bit too much, though. 5 minus 1 is 4. This is negative 512. And then I'm going to go ahead over here and solve this. R sub 4, or R raised to the 4, not sub 4. That's wrong. Divide, isn't that 256? And then I did go ahead and go to my calculator. And then I showed the other hours, well, actually only third hour so far, how to find the 4th root button. And actually, this button is also on scientific calculators. And the button for the graphing calculator is at math, and it's number 5. Problem is, though, if you have an older calculator, it gives you the X root button and not that. So for people that have an older calculator, type 4 first, then math, and then 5, and it still inserts it as a 4th root. Okay, so 4th root of 256, enter. here's the issue. Did anyone know that, by the way? Did anyone know 4 was going to be the answer? No? Okay. Here's the problem. Just like in square roots, though, this could be plus minus 4. That's what I didn't want to actually have happen to you right now. But it is possible, because a negative 4 times a negative 4 times a negative 4 times a negative 4 is a positive 256. It is. So there's 2 possible answers, just like in square rooting. So my general formula for this is G sub n. You know what? We got to make a choice. I'm going to use negative 2 as my term, but this is a sub 1. So it's plus or minus 4 raised to the n minus 1. Why? Because of everything I just went over. And it's because of what's given to me. I'm only given a sub 1 or g sub 1 or g sub 5. And it doesn't have to be g. We could call it a. They're just trying to use g for a geometric scenario. I'll hardly ever use g the rest of the way when we do this. And now, what do I have to do to find g sub 10? I'm actually going to have 2 different computations for this. The first term times raised to the 10 minus 1 power, which is 9th. So why are there 2 answers? Because this could be 4 raised to the 9th as my multiplier. Wow, I do love math. That was fun. Ooh, a little heart. What the heck is that? All right. 9th, and then or, geez, I didn't want this to happen. I didn't want this plus minus thing to occur. It is true, though. And then beep, boop, bop, boop, type it on your calculator. You get big numbers. All right. We'll try to avoid that plus minus thing when we get to a quiz. Really just want to get, the idea down and not worry about these little extra things. Okay. All righty. Good. And now we're at the end and it's almost over anyway. Okay. And now let's look at the directions. What are these? Are these arithmetic? Are they geometric or neither? What's this first one? Arithmetic or geometric? Okay, why is it arithmetic, everyone? What's the common ratio? I'm sorry, what's the common difference? Plus 5. You know what you could do then? You could actually write a formula. This is arithmetic and you might as well. We might as well, because it's actually easy. What is this term? By rule, what does it have to be, though? A sub what? This is a sub 1. So just leave it. We are going to do this as a sub 1. The common difference is 5. This must be n minus 1, though, because it's the first term. All right, and then you could go ahead and simplify and distribute and all this other stuff, but you don't really have to. You could write that as a final answer for this formula. Or, watch this. You want to get nuts? Let's get nuts. What if I put 13 in here? What should this be then? N minus what? What term is 13, everyone? 1, 2, 3, 4, 5. So this could be n minus 5. This is the whole point. You have options. If you distributed and simplified, both these answers would be the exact same. 5n minus 5, and then subtract 12, or 7. So that's 5n minus 12. 25 negative plus 13, guess what? That's negative 12 as well. Both of these simplified to the same thing. You know what negative 12 is? What term is negative 12 then? The 0th. If I subtracted 5, I get negative 12. That'd be the 0th term. Okay, so anyway, you have a million options. Hey, what's this one? Arithmetic, geometric, or neither? It's neither. This oscillates between positives and negatives. It doesn't go up by 1. And it doesn't have a common multiplier to get from one term to the next. So this is a neither. Okay, what's this one? Arithmetic or geometric? Almost done. Geometric. Let's just do one formula then. It is divide by 2 or multiply by what really is what we got to write. Multiply by what? It's a fraction. Half. So, fine. You know, I'm almost never going to do g of. It's always going to be a sub n. Even though it's geometric, you can just call it a sub n. 10 times 1/2. What's the power here? See if you were listening. What's the power I put there? What term is 10? A sub what? So what do I put in here? N minus 1 because it works. That's why it works. Because now what I'm supposed to be able to do is plug in 1. 1 minus 1 is 0. Half of the 0 is 1. 1 times 10 is 10. I'm supposed to be able to plug in 1 and get 10. I'm supposed to plug in 4 and get 5/4. I don't want to hurt your head on this, but when I plug in 4, 4 minus 1 is 3. 1/2 raised to the third is 1/8. 1/8 of 10 is 10/8, which reduces the 5/4. So I did want to show you that that does create the fourth term as well. Arithmetic or geometric? Arithmetic or geometric? It is one of them. It's arithmetic. Why? This is in the form of a line. B plus mx. What's my common difference then? What do these go by? Up or down? Down by what? 7. And what term is this? Be careful. That's the a sub 0 term, because it is in that nice clean format. So 2 is the a sub 0 term. I can prove it. Plug in 0, I get 2. A sub 0 is 2. Okay, but because it's in this format, it is arithmetic. You will see a common difference of -7 if you list out the numbers. What's this one? Arithmetic, geometric, or neither? Ooh. This is a neither. This is geometric. Why? What's the common ratio? What's the common ratio in number 12? What's the common multiplier? 2. What term is 4? What term is 4? A sub what? 1. It is a sub 1. Because when I plug in 1, I would get 4. 1 minus 1 is 0. 2 to the 0 is 1. 1 times 4 is 4. And then anything else would represent a multiplier. If I found a sub 2, I would get 8. It would, because there's a multiplier of 2 here. Right? 2 minus 1 is 1. 2 to the first is 2. 2 times 4 is 8. A sub 2 is 8. So that's why this is geometric. So recognizing the patterns, recognizing the formula is very important.